Hi everybody, this is Mr. Fowley and welcome back to part 2 of 2.2. We talked about metallic properties, talked about non-metallic properties, and what I wanted to talk about was semi-metals are also called metalloids, and they typically are not the average of the two. It would have like 3 metal properties and 2 non-metal properties. So it would pick, that's hard to predict. So it might have this one and this one, but this one, and this one. So it's not that it's an average of the two. It's some of the left and some of the right. And down here it says which properties are chemicals and which are physical. The chemical ones are the ones that say reacts with. All others are physical. So next up, regions of the periodic table. Lanthanide, actinide series, I did that. This is the lanthanide. This is the actinide series. Transition metal, we did this. This is transition metal. And the lanthanide and actinide together are also called the inner transition metals. So that was simple. Ohana means family. That's Lilo and Stitch. You don't need to write that down. Lilo and Stitch say family means nobody is left behind or forgotten. Chemists say families are columns on the periodic table and have similar properties due to their electron configurations. That's the most important part. Nuclear attraction and size we'll talk about more in the next one. But electron configuration says that their properties are similar because of the electron configurations. Learn the names of the families of the A elements, which are called the representative elements, which are these guys right here. Alkali metals are this column. Alkaline earth metals are this column. Halogens are right here. Halogens. Doo-doo-doo. Noble gases are right here. And then this group right here is called the boron group. This group right here is called the carbon group. This group right here is called the nitrogen group. And this group right here is called the oxygen group. Remember, you'll have a periodic table, so if you can remember B is boron, you're golden. C is carbon, woohoo, and is nitrogen, O is oxygen. Charges again. I'm going to erase this and go over the charges again because you must know the charges. So if I asked you, please give me the charges of S, Al, and Na, you would go, oh, let me relabel it. +1, +2, +3, 0, -3, -2, -1, 0. Sulfur's charge is -2. Aluminum's charge is +3. Sodium's charge is +1. Make sure you know those. Electron configurations are periodic. So what I'm going to do is I'm going to write right here. Hydrogen ends in 1s1. Lithium ends in 2s1. Sodium ends in 3s1. Potassium ends in 4s1. Periodic. Look. And it's going to end in S1, 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 S1. Over here, these I'm going to ignore helium for a while. This one's going to end in 2p6, 3p6, 4p6, so it means it's repeating. Starts at S1, ends in p6. Starts in S1, ends in p6. Starts in S1, ends in p6. So this is S1, this one would end in S2, this one would end in P1, P2, P3, P4, P5. So if I said, what's the ending configuration of arsenic? You'd go 1, 2, 3, 4. It would end in the 4th block, P. Okay. And these guys are all the D1, D2, all the way down to D10, with exceptions that Excel needs to know. And this would be F1, F2, all these guys, all the way up to F14. And looky. Oh, come on. Change the slide. You can do it. Oh, my goodness. Well, that's the end anyway. So even though it won't work for me, that is the end of the end of the end. So there is no part 3. That's the end of part 2. I will simply say to you, toodles.